Okay, so picking it up again here with the punch card tabulator. So, never satisfied, right? Punch cards were next. So then around the late 1800s, so there was this Hallrith's electronic calculator, right? This tabulator. And following the 1880 census, the Census Bureau, they were trying to collect more data than they could actually tabulate. And so as a result, they had a competition to find a more efficient way to collect and tabulate the data. So the contestants were asked to process the 1880 census data from 4 areas around St. Louis, Missouri. And whoever captured and processed the data the fastest, they would win the contest for the 1890 census tabulation. Now, 3 contestants accepted the Bureau's challenge. The first 2 captured data in about 120 hours each or so. But the third contestant, a former Census Bureau worker named Herman Hallrith, he captured the data in 72 hours. So significant difference. And then afterwards, the contestants had to prove that their designs could actually prepare the data for this tabulation, right? By age, by category, race, gender, etc. So 2 contestants tabulated that data in about 47 or so hours, but Hallworth's machines did it in 5.5 hours. Whoa, what a difference. So this was very impressive, and the results earned him the contract to process and tabulate the 1890 census data. Now, modified versions of his punch card technology that he used would continue to be used by the Census Bureau until the mid-1950s. It would go on that long. Very effective. So, other data-intensive organizations found punch cards very useful then. But there were other tools required, like a sorter, right? And this other equipment was used then to speed up the punch card processing, which became the very next focus. IBM actually had sophisticated machines that developed around punch cards. So the other machines that would come up would be punch card punchers, card verifiers, tabulators, alphabetizers, etc. This created a data processing system where IBM would later play a key role in its growth. Now, not all technology is used for good. IBM's role wasn't always glorious, for example. Their machines played a role in the Holocaust, allowing the Nazi government to rapidly conduct a census, identify acknowledged Jews and their related ancestors, and alphabetize their names and assets, and etc. So, as it relates to this course, we have this IT ethics and law class, right? Decisions have to be considered for second and third order effects, I would offer. Even at the time, the Nuremberg laws of Germany would allow, they prescribed this collection of information. So the law wasn't being broken. Still, there's the ethics and morality side of it that we want to consider. And we'll discuss that in the following weeks. Now, between 1939 and 41, over in Iowa State College, they were constructing an electronic device to solve linear equations. So, as you recall from one of your math courses, a linear equation is any equation that be written in the form of ax plus b equals 0, right? Where a and b are real numbers and x is some variable. Basically, remember when we used to use graph paper to plot out an xy axis and plot points? That's basically a linear equation. Okay, so from there we get programming turned to the ENIAC, right? ENIAC, which stood for Electronic Numerical Integrator and Computer. This was really the first electronic general purpose digital computer. It was able to solve large class of numerical problems through reprogramming. Look how big it is. Isn't that funny? So UNIVAC which is short for Universal Automatic Computer, was the successor, the follow-on to the ENIAC computer. And it was famously used to predict the outcome of the 1952 presidential election between Adlai Stevenson and Dwight Eisenhower. Adlai Stevenson was supposed to win and was ahead on election days, but the computer actually predicted Eisenhower in a landslide, and that Ike would win some southern states, which at the time was unheard of for a conservative, for a Republican. So as a result, like Kleenex is kind of universal when it comes to tissue paper. UNIVAC became universal for computer in the 1950s because it successfully and accurately predicted, and Eisenhower did win in a landslide and win some southern states. Here's a picture here. They had worked with CBS News, the UNIVAC, to use the UNIVAC computer. Right, so television makes its foray into predicting these presidential elections based on computer analysis of early returns. And the UNIVAC computer, of course, was amazingly accurate. And then no one thought it would be credible, but it certainly was. So this UNIVAC was this next gen version of the pioneering ENIAC computer that we had just spoken of. And then Remington Rand bought a computer corp, and in 1950 sold this UNIVAC computer, and it was on its way, right? It was an 8-ton walk-in computer. It was the size of a one-car garage, accessed by hinged metal doors. And they would cost about $1 million a piece, or more than $8 million, or about $10 million maybe in today's money. And of course it had thousands of vacuum tubes. We're going to talk about that transition, which processed, an amazing at the time 10,000 operations per second. It was really quite slick. Okay, so in the early days, every instruction had to be coded with a long set of zeros and ones. One early improvement was the creation of an assembly language, right? So we're getting to this next phase, right? I can't just code everything with zeros and ones. I need a language to help code faster. So IBM, again to the front, created Fortran, which was short for Formula Translating System. And it was designed for scientific applications. And most programmers shifted their allegiance then from that sort of assembly language of just ones and zeros to using Fortran. Then other manufacturers would come about, and of course, they didn't like incompatible languages, right? Because one brand of computer had to be rewritten for another brand. So the Department of Defense actually brought everybody together, did a study, and decided COBOL would be required for manufacturers to get contracts or work with the Department of Defense, and that became then the next evolution. Now, the development of the language BASIC, right, a simple and easy to learn programming language, this was another major step toward making computers accessible to a wider audience. And the original version of BASIC was designed at Dartmouth College in 1964. Now, moving from the languages, right, we have the processing capability. So in World War II, there were some folks that did some microwave radar work, right, which required high-frequency receivers utilizing semiconductors. You see some pictures of these on the right. AT&T used this concept then to develop the semiconductor substitute, replacing now the vacuum tubes, and it was called a transistor, right? Transistors made of semiconductors. This is replacing the tubes in the construction of computers. And by replacing the bulky and unreliable vacuum tubes with the transistors, computers could now perform the same functions using less power. Using less power and space, actually. And you see by just the sheer size of them on the right. So the miniature size. So before transistors, digital circuits were composed of these vacuum tubes, and now we're able to replace those. And so the evolution actually continued to produce a single semiconductor device containing transistors, capacitors, and resistors. It's the way electricity works and talks to each other, right? Stop, go. And this became an integrated circuit, right? Which is an electronic circuit formed when a small piece of semiconducting material performs the same function as the larger circuit made from discrete components. You see a semiconductor in the bottom picture, okay? Now, the integrated circuit can be passive devices. A passive device or component doesn't generate energy, right? But it can store and dissipate it. So passive devices are the main components used in the electronics, such as resistors, inductors, capacitors, and transformers, right? Which together are required to build any electrical circuit. So here's some folks at the Fairchild Semiconductor. They were the founders, and they would go on to play a very important role, creating really the first truly integrated circuit. Now, the integrated circuit made possible the construction of even more power computers, right? And here comes IBM back again. They have a family of mainframe computers announced in 1964, and they continued to deliver these up until almost 1980. And it was the first family of computers, right, to cover the complete range of applications from small to large, commercial and scientific, and they were reliable computers, right, a major step forward. Here is a picture then of this all-in-one computer that could do everything. Compare that to today's all-in-one computers. It's just very funny to me, actually. So then along comes a fellow named Gordon Moore, right? He's of Moore's Law fame. And he left that Fairchild Semiconductor company to found Intel. And Intel created a general-purpose chip that could be programmed to perform a wide variety of tasks, right? The Intel chip, Intel inside, right? So the microprocessor made it possible to integrate the computers into everyday devices, this little tiny microprocessor, because it contains all the functions of your CPU, right? Managing pulls from memory, doing calculations, and organizing commands, that sort of thing. So goodwill abounded at this time, right? And there were organizations trying to help people get a grasp of this new technology. For example, the People's Computer Company. It was a non-for-profit dedicated to educating people on how to use computers. It was really an outgrowth of a group called the Homebrew Computer Club, which became a meeting place for hobbyists, right? So progress, though, at this time was slowing down, right? Due to a lack of this higher programming language that was becoming required. And that's when we reunite, so this Altair 8800 computer with this basic language, this basic interpreter, which Bill Gates was a part of founding this language. And they entered the picture. They had a tiny company called Microsoft, and they went to a conference, and actually their basic program was stolen. And later, Bill Gates would say that the theft of the software created very little incentive for his company to release new products, right? We'll consider that in future conversations. Here's a picture. By the end of the 70s, many computers, including Apple and Tandy, were producing personal computers for home use, though, through these languages and these microprocessors and these integrated circuits. But businesses were reluctant to participate. We're going to pick that up the next time we get together. Thank you.